So we're going to move on to Unit 3 today. Unit 3 starts off with solving equations. Hopefully you guys remember a little bit about solving equations from pre-algebra. I first want to give you a little visual. Whenever we're solving equations, we want to think of it like a balance scale. Hopefully you guys all know how a balance scale works. I want it to be balanced the whole time. If I add more weight over here, then my scale is going to go this way on this side and this way on this side. Same thing if I add weight over here, this side's going to go down, this side's going to go up because this side is heavier. So if I have the same amount of weight on both sides, then it's just going to stay perfectly level and perfectly equal. So let's say I have some sort of mystery weight over here. Say that's a question mark inside the box. And then I've got a few things that are 1 pound in there. Then over here, I've got 4 1-pound weights. Now you could very easily tell how much this question mark weight weighs, but for our purposes, let's just pretend that we don't know how much that one weighs. If I add another 1 pound weight to this side, I would have to add another 1 pound weight to this side over here to keep it even. If I subtracted a 1 pound weight from this side on the left, I would have to subtract a 1 pound weight from this side on the right as well to keep it balanced. So if I want to find this question mark, this unknown weight, I'm essentially trying to get that weight by itself with the same amount of blocks on the other side that it needs to be balanced. So in order to get this question mark by itself, I would erase the 2 1 pound weights, and since I subtracted 2 1 pound weights from this side, I need to subtract 2 1 pound weights from this side to make it level again. So now I know that the question mark is equal to 2 pounds. So I want y'all to keep that visual in your mind as we're solving our equations today, because we're essentially doing the same thing. So let's get into some examples. It says solve each equation and check your solution. For number 1, we have x minus 3 equals negative 5. My equal sign is the middle of my scale balance. Both sides to the left of that equation and to the right of the equation are equal. That's what an equation means. They're balanced right now. So I'm trying to solve for my unknown weight right here. This variable, it's my unknown value. So I'm trying to get it by itself. So we're going to use what we call inverse operations to move things around to get x by itself. I've got x minus 3 on the left side of the equation. The inverse of subtraction is addition. Inverse of addition is subtraction. So since I have subtraction right here, or it's a negative 3, in order to get rid of it, I need to add 3. Because negative 3 plus 3 would give me 0, so they cancel out, and so I'd be left with x by itself on this side of the equation. Now since our equation is a balanced scale, whatever I do to one side of the equation, I have to do to the other side as well. So I have to add 3 to the right side. So on the right side I get negative 5 plus 3, which gives me negative 2. Now my variable is by itself. I have solved the equation. Now if you notice, it says check your solution. So we need to plug our number that we got for x back into our original equation. Negative 2 minus 3 equals negative 5. And now I'm just using my order of operations to work down both sides of the equation. My right side is already worked out. There's nothing I have to do to it. And then on the left side of my equation, I just have to do negative 2 minus 3. That gives me negative 5. Negative 5 does equal negative 5. That's a true statement. So I can be confident that my answer is x equals negative 2. On your assignment, if it tells you to check your solution, you must check your solution, otherwise you're going to get it wrong. So check your solution if it asks you to. Let's move on to number 2. We have 0.9 equals y plus 2.8. Once again, I'm trying to get my variable by itself. So now I have y plus 2.8. Like I said earlier, the inverse of addition is subtraction. So that's a positive 2.8, so I need to subtract 2.8 from both sides. Whatever I do to the right side, I have to do to the left. 0.9 minus 2.8 gives me negative 1.9 equals y. My variable is now by itself, so I have now solved my equation. Once again, we need to plug back in to check our solution. So I get 0.9 equals negative 1.9 plus 2.8. My left side's already worked out for me. Negative 1.9 plus 2.8 gives me 0.9. That's a true statement, so I can be confident that the answer is y equals negative 1.9. Hopefully that makes sense. If you have any questions, please let me know. Let's move on to solving one-step equations continued. So on the previous slide, we used addition and subtraction to solve our equations. Now we're going to use multiplication and division. So addition was the inverse of subtraction, and vice versa. Subtraction was the inverse of addition. Same thing with multiplication and division. Multiplication is the inverse of division, and division is the inverse of multiplication. So on letter A, I have negative n over 5 equals negative 3. If I have a fraction, that's just indicating division. N divided by 5. So I'm trying to get n by itself once again. That's my goal for solving my equations. So to undo my division, I have to multiply both sides by negative 5. That negative 5 is going to cancel with my denominator, leaving n by itself on the left-hand side. And then negative 3 times negative 5 gives me positive 15. The variable is now by itself, so my answer is n equals 15. Plugging back in to check my solution, negative 15 over 5 equals negative 3. Negative 15 divided by 5 is negative 3. That's a true statement, so my answer checks out. Moving on to letter B. Letter B, this should be pi x equals negative 2 pi, not negative 2x. I apologize for that. That was just a typo whenever I was typing these notes. So I'm solving for my variable. You may be saying, hey, I've got two variables there. But remember, pi is just a number. 3.14159 goes on forever and ever. We just use this symbol to represent it. So it is still a number. So I have pi being multiplied by x. So in order to undo that, I just have to divide both sides by pi. I apologize if you are watching this video. I just paused my recording and I kept teaching, so I don't remember where I left off. So I'm just going to say this is where I left off, and I'm going to move on from here. So we're moving on to solving multi-step equations. It says solve 2.5x minus 13 equals 2. I now have more than one step that I need to do. Earlier, it was just either add, subtract, multiply, or divide by a number to solve for my variable. Now I've got to do more than one step. So my first step, we want to think kind of backwards from the order of operations. So you might be thinking to divide by 2.5 first. But like I said, we kind of need to go reverse of the order of operations. So I need to actually add 13 to both sides first. So I get 2.5 x equals 15. And then now I just have a one-step equation. I can divide both sides by 2.5. And I get x equals 6 for my answer. Plugging 6 back into my original equation, 2.5 times 6 minus 13 equals 2. Now I'm using my actual order of operations to work down both sides. 2.5 times 6 gives me 15. 15 minus 13 gives me 2. That's a true statement, so my answer checks out. Moving on, number 1 on this first slide, or on this slide, the first problem on this slide, negative 12 equals 9x minus 6x plus 15. Some of you may be thinking I might need to combine my like terms right off the bat. You would be correct in thinking that. Whenever we're solving equations, I need to first see if there's any simplifying that I can do on either side of the equation. My left side has no simplifying that can happen, so it just stays as negative 12. Combining my like terms, I get 9x minus 6x is 3x. Then I have my plus 15. That is all the simplifying I can do. So now I can start solving for my variable. Subtract 15 from both sides. Get negative 27 equals 3x. Divide both sides by 3. I get x equals negative 9. That'd be my answer for number 1. I do need to plug in to check my solution. You may be asking yourself or me, which x do I plug into? Well, anywhere I see an x, I need to plug in negative 9. So I'm going to get negative 12 equals 9 times negative 9 minus 6 times negative 9 plus 15. And now I can just work down both sides of my equation. Negative 12 equals negative 81 plus 54 plus 15 gives me negative 12 equals negative 27 plus 15. That gives me negative 12 equals negative 12. So my answer does check out. I know my answer is x equals negative 9. If you're not understanding this, make sure you are asking questions. Let's look at the very last example. We have 2 times 1 minus x plus 3 equals negative 8. Some of you may be thinking to distribute right off the bat. That's perfect. We can do that first. 2 times 1 is 2. 2 times negative x is negative 2x. Then I still have my plus 3 equals negative 8. Combining like terms, negative 2x plus 5 equals negative 8. That's all the simplifying I can do, so now I can start solving for my variable. Subtract 5 from both sides. I get negative 2x equals negative 13. Dividing both sides by 2, I get x equals negative 6.5. Excuse me. So x equals negative 6.5. Now I do want to show you another method we could use. We could treat our parentheses kind of like a variable. So I could solve for my parentheses first and then solve for x. So I'm going to try to get the set of parentheses by itself. So subtract 3 from both sides. I get 2 times 1 minus x equals negative 11. 2 is being multiplied by the set of parentheses, so I can divide both sides by 2. I'd get 1 minus x equals negative 5.5. Now that I got my set of parentheses by itself, I can now start trying to solve for x. Subtract 1 from both sides. I'd get negative x equals negative 6.5. This also brings up a very good point. X is not by itself in this case. It has that negative in front of it, which is like a negative 1. I need to get rid of that. It's negative 1 times x. So I can divide both sides by negative 1. And I would get x equals positive 6.5. So it looks like I've done something wrong on the first time I solved it. My answer is x equals positive 6.5. So let's go back and fix the first method that we used to solve. Figure out where we went wrong. Distributing, I get 2 minus 2x plus 3 equals negative 8. Get negative 2x plus 5 equals negative 8. Subtract 5. I think I just missed a negative sign earlier. Negative 2x equals negative 13. Divide both sides by negative 2. I get x equals positive 6.5. So either way you want to work it out, our answer is x equals 6.5, whichever method you like best. Now I do need to finally check my solution. So plugging x or 6.5 into x, 2 times 1 minus 6.5 plus 3 equals negative 8. I get 2 times negative 5.5 plus 3 equals negative 8. 2 times negative 5.5 gives me negative 11. And then negative 11 plus 3 gives me negative 8, which equals negative 8. So my answer checks out. I do know my answer is 6.5. If I did go ahead and stick with negative 6.5, I would have gotten a false statement over here, which would have told me, hey, you did something wrong, you need to go retry it again. So that's where checking our work comes into play, because if you make a mistake, you can catch that mistake and fix it. I hope you guys understood all that. Like I said, if you have any questions, please let me know. The assignment is page 20, numbers 6 through 30 evens, and page 28, numbers 4 through 24 evens. It's one big assignment put together. It's about 26 questions. It shouldn't take too terribly long though, since those solving one-step equations don't take too long. This will be due this coming Wednesday on Canvas. That's December 2nd. Due Wednesday, December 2nd on Canvas. Like I said, if you have any questions, please let me know. Y'all have a good day.